So in today's session, we'll start with looking at the numerical Python part. So in numerical Python part, I want to discuss mainly a couple of ideas. The first one is I want to look at how we can create vectors and matrices, then vector generation, functions, matrix manipulations, and finally some linear algebra solutions, which actually you can do this. So in numerical Python website, it will actually listed the other related, libraries built on top of this. So for example, if you go down to scientific domain, you will notice that there are many libraries coming of various different areas depend on NumPy. So for example, if you look at starting from quantum computing, statistical computing, signal processing, image processing, graphs and networks, astronomy, cognitive psychology. So all these, you will see all these various different types of modules are built on top of NumPy. Similar to that, you will also notice bioinformatics, spatial inference, mathematical analysis, chemistry, geoscience, geographic processing, architecture, and even engineering. So there are many libraries are used. So if those who are into data science, also you notice that like many of these is actually based on the NumPy, right? So you can notice some of the things we are going to cover. Jupyter notebooks we are already using, and matplotlib, which we are going to discuss in the next session. Scikit-learn is a machine learning library that we are going to start with. Pandas, again, for data representation manipulation, we are going to look at it. Right. So with that said, let's start the session. Now, the first thing that I would like to discuss under this is I would like to discuss how you can actually create vectors and matrices. So when I say vectors and matrices, simply what it means, we are going to look at creating one-dimensional arrays like a list. So the first thing that we need to understand is the similarity of list and NumPy. So if you look at the list as it is, you will notice that it looks the same. We can have a number of elements, but list can support multiple, different elements, right? And in this particular case, if you look at NumPy arrays, so especially when you want to implement very large ones, so the ideally we recommend you to implement using NumPy arrays, right? So that's what we normally do. Give me a second. I want to show you like some slide on this one as well. Right. Right. Let me start with a little bit of starting. So NumPy, and you will notice here about the NumPy stand for numerical Python, and then basically outcome will be the multidimensional ND arrays. So first thing is comparison of both the list and arrays. As you can see, we can comma separate and use square brackets to define a list. And this is what we have. And the NumPy arrays, we have to, import NumPy, and we renamed as NP. And we use array method to define it as a NumPy array. So when you look at it, you see it's coming from two different classes. The first one is how you define something as a simple list, and the second one as an ND array. So the difference would be like you will have more methods, more techniques where you can easily manipulate vectors and matrices when you actually work with NumPy arrays. And especially when you create very large, number of rows and columns. So when you have a huge arrays or matrices, so NumPy will be efficient in the processing perspective. So it is always recommend you use NumPy arrays. Now, coming back to my notebook. So let me define this. So let's start saying that import NumPy. as NP. And the technique is whenever you want to create, you use what we call the array method. So you can get more information just by typing help and np.array. So within this method, you can have a list of numbers. So let's say I have a simple array 1, 2, 3. So let me save this as test. And then if you say print test, it will print as it is. And if you say print type, if you check the type of this, you see it's class numpy n-dimensional array. Right. Let's look at some of the commands, the methods that actually you can use it with together with NumPy. So for that, I will create a row vector. So let me explain how to create row vector. We know, you know what you mean by row vector. Simply you have a list of numbers. So let me say that's A, and we can use the array method like this. And then within this, let me have 4 values, 1, 2, 4, 5. So you can notice that, so this is how we can define it. So if you print it, you don't see any difference. It looks same as list, but slightly different if you notice that there's no comma. But of course, the same way you can access each integer items. So if you say print type A, we have already witnessed that it's an n-dimensional array. So there are 2 commands that actually you can get the number of dimensions and number of elements. So if you use a.shape, usually this will tell you the number of dimensions, right? So let me run. So if you run it, it says you have 4 elements. Actually, if you have both row and columns, it will tell you the number of rows and the columns. And a.size will give you a number of elements. Right. So now you can see there are 4 elements. Individual accessing will be same as in the list. So I think we discussed in Python, it starts with the index 0. So if you want to access the first item, we say in all. So that's how we can access the first item. If you have finished, just let me know by raising your hands. Right. So in this one, what we have discussed is how to create a row vector. Simply we use NumPy array method and we define it as a simple list, right? And we discuss how to print it, how to get the type of it, how to get the number of dimension in rows and columns, how to get the number of elements, and how to access the first item. Right. Let me move to the next one then. I'm going to get another code window. Right. The second one in vectors, we use column vectors. So in this one, I will explain how you can use column vector. One of the beauty in NumPy is when you print it, right, it will print it as it is. Let me explain. Now, for example, when you have a column vector, we will have nested list. What it means, you have each row you put in a list. So you have a single item. So we'll have 1, then 2, 4, and 5. Right. And then we can say print P. Just observe that it looks, when it prints as it is a column vector, which is visually easier for you to understand as well how the a particular data structure. For example, metrics will show in the matrix form. This you might have not seen in when you represent it using just lists. Right. Now, if you just now take b.shape, this time you will notice that it will tell you you have 4 rows and 1 column, right? And when you use b.size, it will tell you like, okay, you have just 4 elements. Right. In this one, what I'm going to explain is how to generate vectors using a range, array range. It's similar to range function. You have three parts like start, stop, and step, right? So for example, let's create a vector. Vector consists of numbers from 1 to 10. Can you give me the command? Because already you know that. Let me say this is 1 to 10 vector. Yes, np.arrange. Yes, can one of you tell me like how to get numbers from 1 to 10? What should be the starting value? That should be 1, right? What is the stop value? Yes, that's 11. So if you do that and if you say print, and if you run this, you get a simple vector which consists of numbers from 1 to 10. Simple example exercise. Yes, give me the answer for the exercise in the chat answers. So if I say it as odd vector, I can say np.arrange. Okay, 1 to 10, so 1 comma 11. And you can even have two, there's no point because if you have odd numbers, it start with 1 and with 9. So I put 11 here, just putting including range 10, but you can have 10 as well. And if you say print odd vector, yes, you will notice that you have odd numbers from 1 to 10. Okay, right. One more. Simple example, yes, exercise. Let me to create a vector consists of numbers from 10 to 1. Yes, can you uh, create a vector from numbers, including numbers from 10 to 1, which means 10, 9, 8 up to 1? Try it out. And nullify as well. Okay, so starting from this, we can say, okay, 10 to 1. Actually, you can notice now, nowadays we are getting automatic answers. So it says 10 to 1 vector, nb dot arrange from 10 comma 0. Yes, because you have to stop at 1. So less than 1, it will be 0. Then the step is -1. Okay, good point. Next, I would like to explain vector generation. Generation, this time using linspace. Right. What do you mean by linspace? It creates a linearly spaced vectors. Let me explain. Right. I'm going to create a vector. Let me say y np.linspace. Just try this, will you? I will put 1 comma 100. So you have a start and stop, but you have to be very careful. In this particular case, it includes both 1 and 100. So if you print y, notice that this will generate a vector which consists of numbers starting from 1 to 100. So notice this first. So how many data points are there? How many data points? So if you want to know how many elements, you can go y dot size and it'll tell you 50. So actually what happens here, this command will generate 50 points between 1 and 100. And you can notice 1 and 100 is there. There are 50 points. So more information you can get it by typing, you can type help np.linspace, right? And if you read this, you can say linspace starts and stop. It says number is 50. The third one is number of data points. It says even space number or a specified interval. Okay, quick question. If I want to get 100 points between 1 and 100, what should be my command? Create a vector which consists of 100 elements starting from 1 to 100. So what is the command? Okay, I already got the answer from Ashka and then Pabasara. Thanks. So let me say this is y np.linspace. Starting value is 1, end is 100. How many data points? We just put 100, or we say num equals 100. So if you print y, yes, now you notice there are 100 data points, right? Yes, can you see? So if you carefully look at the element inside this vector, you will notice that there's a decimal point, which indicates that it's floating point numbers, right? So in case if you want need integer values, this is how you may handle it. So let me try out. So for example, if you want to have like integer values, then you can say d type, which stands for data type, and you will say int. So if you put it in this way, now you can get integer vector, integer vector, which consists of numbers from 1 to 100. Next, I will discuss about how to create matrices. So matrices, right? We can think of them as 2D arrays. So simply, if you want to develop, let's say, matrix A using the NP-array method, the idea is you have a list of lists. So let me create a 3 by 3 matrix. I'm going to have 1, 2, 3. First row. Second row, let me put 4, minus 5, 6. Second row. Third row, let me say 5, minus 6, and 7. As I told you earlier, the beauty of this is when you print A, you will visually see a 3 by 3 matrix. Okay, I have comma. Yes, you will notice that we have a 3 by 3 matrix, right? In similar way, if you take shape this time, so the shape will give you, it's a 3 by 3. Size will give you, there are 9 elements. And let's say if you want to access the middle element, we can say A middle element. So A1 give you the second row. And then you have a second column. This is one way, right? The other way is you can comma separate them, print. This is possible with both. The previous one is possible with list as well, but the second one will not work. So we can say 1, comma 1, right? So this is how we can create matrices. Right. So in this section, I'll explain how we can generate matrices. So we can say generating matrices, right? There are many algorithms. Let me share the slide. You will get the slides for this one as well. So if you look at the slide, so here are the list of commands that I'm planning to discuss. We can fill matrices with ones and zeros. So there are two methods, ones and zeros. Then there is a method to generate identity matrix. Identity matrix means you have one in along the diagonal and all the offline elements are zero. So then there are two methods for random matrix generation. We have rand method and we have rand-n for normal distributions. And if you want to create integer values, we have rand-int, right? So let me go through each and every one. And I'm going to explain how to use them. So let's get back to our notebook. Right. So let me start with the ones. So the idea is we'll create vectors and matrices. Actually, you can use it to create even the vector and matrix as well. So let me first use np.ones. And we will put 5. So ideally what you get is you will create a vector which consists of 5 ones, right? If you want matrix, let's say you need 3 by 3 matrix, right? We'll put 3 by 3. So this is in that way we can say np dot. Right, you get notice that. So like the same principle applies here as well. For example, let's say I want to create 3 by, let's say 2 by 3 matrix, right? Remember, you have to make it as a tuple. So this is something that I also confused in the very beginning. And if I want to use it as an int, make sure that you properly. Okay, here also I made a mistake. Yes, I think now it's correct. So one thing to note is you can see, if you look at help, you will see that you have to put this as a tuple, the number of rows and the column. The size is what we are going to specify. Right, good. That's about filling ones. Same as you can put zeros as well. So which I'm, okay, let me put the same code here. Right, in this, instead of ones, if I use, right, zeros, we'll get 3 by 3 matrix which fill with zeros. Next, identity matrices. So identity matrix usually is symmetric. So therefore, you don't have to specify both rows and columns, assuming that one. So we can say print np.eye. This is identity matrix. So if you need 3 by 3, of course, you get a 3 by 3 matrix which fill with ones in along the diagonal, and all the off diagonal elements are set it to 0. Right, so that's ones, zeros, and then identity matrix. The next interesting one is how to generate random numbers. Again, very important in some of the applications that can be applicable in anywhere. Even in machine learning models, we know that the randomness is applied there. So therefore, generation, we should know how to generate random numbers. So with that said, let me first explain how to use rand method. So rand actually generate random numbers from uniform distribution over 0 and 1. So the command is, we can say print np.random .rand5. So if you just apply a value, that will generate just a single array which consists of 5 random values. So similar way, if you need, let's say, 3 by 3 matrix, right? We can say print np.random.rand. Okay, we can say 3 by 3. So which will generate a 3 by 3 random matrix. Next one is, if you use, instead of rand, if you use rand n, you can make a note of this and it will come with the note. I will have everything in the note as well. So this will generate random numbers drawn from standard normal distribution. So in that particular case, we can use the same thing. We can say print np.random.rand rand n, remember, 5, which will generate just 5 random numbers, an array of random numbers. But if you need 3 by 3, for example, we can say rand end, we can say 3 by 3. Right. So that's about how to generate random numbers using this time rand end. Same thing, instead of rand, we use rand end. The last one on random, okay, how you may generate random integers. So that's slightly different from these two methods. So let me explain that next. Right. First one, let's say I want to generate just one random number. If you need just one random number, you can say np.random.randint, and we specify start and stop. So you can always refer the help if you need more information, but simply if I explain, so this will generate a random number between 1 and 100, right? Run it. Every time you run it, you will get a different value. Right? The second one, I think it's a seed. Let me check the help. Help.np.random.seed value. Yes, you have. Okay, seed. Okay, right. Let me put this one this way. Seed. Okay. Same thing. I'm going to copy this time, and let me explain what a seed means. I think I put 1. Let me see. Yes, every time. Okay, so now I think I can explain. Now let me explain this idea. So the randomness is good. So for example, the first one, when I run it, every time it will give you a random number. This is okay, right? Getting random numbers. But sometimes you have to have a control of this random number. Now think about, you are going to have a machine learning experimentation, and if you want to share the same state with somebody else, and if you're using random numbers, you have a bit of a problem to reproduce the result because it's random. So therefore, we can set something called a seed value, and you can have any integer value here. But as far as you use the same integer value, everybody should get the same random number. Yes, this 38 is a random number. But if you say the seed is 1, you have control over the random number, and you will get the same value. So make a note of this, again, very important idea. Randomness is good, but what we really need is a pseudo-random, which means we have to have a controlled randomness. And that's what I did it here. By putting random seeds to 1, I control the random number. So every time if anybody uses seed value 1 and with the random generation, it will generate the same. Okay, make a note and also like try this. And once you finish, just raise your hands. Just let me know. Right. Shall we move on to the next one? Right. So I hope now you have a good understanding about how to generate random numbers using three techniques: rand, and stellar and int. The next I'm going to explain to you like how you may access a matrix. So for that, I will generate 4 by 4 matrix using some methods. Just observe what I'm going to do. Right. I'm going to use np.arrange. I'm going to generate numbers from 1 to 16. Right. Yes, you can notice. So I have generated a number of elements, values from num 1 to 16. And then I'm going to use a reshape, which I will explain to you later on. I reshape to 4 by 4 matrix, and you will notice that I'm getting 4 by 4 matrix. So here I'm getting a matrix which fills with numbers from 1 to 16, a 4 by 4 matrix. So why I actually use this, I wanted to explain like, how to access rows and columns. So since this is supported the rows and columns format, so for example, if you want to access, let's say third row, you can say 0, 1, 2, third row. And then you can say everything. I hope you remember this notation. When you have just colon, what it means is start to stop. So which means you will get row from, right? Maybe I will print X as well, print X, and then we print third row. So you know to say this is the third row. Yes, we get third row. Right. Let's say you need fourth column. So in this one, we say fourth column. So notice that here fourth column is 4, 8, 12, 16. We'll get 4, 8, 12, 16, fourth column. Let's say what is available in third row, fourth column. Third row, we have third row, we have fourth column, that is 12, right? So I'm going to access that. Right, we have third row, that is 2, fourth column, that is 3. Row and fourth column. So look at third column, third row and fourth column, and you should notice 12. You take a part. I want to explain a very interesting idea, what we call the submatrices, right? Let me explain what this is, right? Submatrices means you take part of the matrix. Now, it's like this, like let's say, think about a photo, the picture you are taken from your mobile. And sometimes you are not happy with the background and you may want to crop it. right? That means you are going to select part of an image, which we call in matrix terminology, we call it a submatrix. So for example, let me take the same vector x. So x, we say np dot arrange. We have 1, 17 dot reshape. We'll say 4 by 4. And when I say print x, we'll notice that it says 4 by 4. Now, I want you to give me the output for this print. I will say, okay, we'll do like this. I will say y equals, I will say y equals, I will say x1313. So we use this format for y, and I'm printing y. Can you tell me what is the outcome and what happens here? What we do here? So you can notice that in this one, we have a 4 by 4 matrix which filled with 1 to 16. And then we are taking part of it. We have x1 colon 3 comma 1 colon 3. So x, we have rows goes from 1 colon 3. That means you select the second and third row, not taking on the fourth row. So you have 2 rows. So you have second and third rows, and the second and third column where it meets. That's mean the middle part of the matrix. We have 6, 7, and 10, 11. So that's why. Okay, what I want to do is not just one. So tell me what will happen now. I'm going to say y, colon, comma, colon. And I'm going to say this is 0. So what is y now? Any guesses? What is y now? Yes? What happens? If I run this, I didn't run this. I select part of the matrix as y, and I put this command. My question is, what happens? What are the values of y? What we say here, each element, we say 0, right? Colon and colon means start to stop. All the rows and all the column, that means the whole y matrix, we filled with zeros. So that's what happened when I run it. So observe, when I run it, we have y is 0. Now, if I say print x, what will happen? Last one. If I say print x, what will happen? Yes? Any ideas? So then all values are 0, but what if I say print x? Will it be the original? Will it be modified? Okay, so you might assume that it's no change to x. So this is what I want to clarify. If you know closely look at x value, you see the middle part will be 0. It is because when I make a copy of this is a view of x. This is called view of x. The y is a view of x. So I will put in that way. We have to say this y is a view of x. What do you mean by view? So it's actually not a copy of it. So it will not create a copy. It's just a view of it, right? So therefore, if you change y, it affects x as well. That's why you end up getting modified the x value. So make a note of this. So when I assign this y equals x 1 colon 3 comma 1 colon 3, we take a part of x and assign to y. But this will be a view of x. So if you make a change, what do you mean by view? If you make a change y, it will affect x as well. So make a note of this. The next, I will explain how to avoid this. I'm going to copy the same thing, right? I'm going to get the new, and this time I'm going to put a simple, say copy. So what happens, right? Y will be a copy of x. y will be a copy of x. And if you run this time, you will notice that there's no harm to your original matrix x. So make sure that when you work with multiple matrices and when you want to make copies, make sure that you use the copy method. You use copy method. Exactly. Right. So that's about the submatrices. When you're using submatrices, you have to be very careful. If you're not very careful, that you might lose some information from the original. Right. Done? Finished? Just to elaborate what we have discussed, when you take a submatrices, you have to be very careful. If you directly assign a part of the matrix and if you make a modification, so it will affect your original matrix. It's like you get a picture from your camera and then you get a part of it. Let's say you crop it, and if you modify and save, it will, you lose the information about the original. If you make it a copy of it, make sure you use a copy method. Then you will get a copy of the y will be a copy of x, and then any changes to y will not affect to x as well. So make a note of this, and very, very important. The next thing that I would like to discuss is again very interesting idea. It's called fancy indexing, or we can say Boolean indexing. So this is useful operation. So where you can actually select the part of the data based on some conditions. Now to elaborate that, I'm going to use a simple array. I'm going to say A, and I'm going to use linspace. So you know that linspace, what it does, it can create a space vector between 0 and 1, and we specify how many elements. I will say 11. And if you say A, this is what you will get. You will get 11 points between 0 and 1. And then the next thing that I want to discuss is you can give it the inequality. Like, for example, we can check whether the values are, whatever the values inside the A is greater than 0.5. So in that particular case, you know that this is an inequality. You get true and false values. So this will be false, 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 and this will be true, 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 true. So there are 5 trues and 6 false. So you can notice it here. Now, beauty is not like that. If you use together with A, then you will get only data which satisfy this condition. For example, if you choose A naught, we know we are accessing the first element. That means 0. But if you use this inequally within this, A greater than 0.5. So what happens? You return only those conditions are satisfied. So we have to say A. Right? So you can notice here, so all those values which are greater than 0.5 will return here. You will get 0.6, 7, 8, 9, and 1. Right. Good. Any questions? Right. Let me move to the next one. I will explain this again when I talk about the graphical elements. Like, for example, let's say you have a data set with 3 different classes. We want to separate out instance based on the class value. of course, we have to use this technique. So I'll explain that at that time. So the next couple of commands, the first one I want to talk about the reshape. We have already seen reshape. So what it means, like we can get an array and then we can transform it to matrix. So for example, if you say arrange, and if I say 12, right? And then we'll say reshape 3 by 4. So simply we get a set of values from 0 to 11. When you say 12, the start with 0. And the reshape 3, 4, we get 12 elements in this form. Of course, you can use together with the randomness as well. So let me give you one more thing. If I use random dot rand, let me put 12 values like in early, but reshape into 3 by 4. So you get a random set of values. So in other words, this is what you need to know, the basics of rows and columns. Next, I'm going to explain you how to concatenate. Concatenate means combine matrices. So where this is useful, you can combine data sets, you can combine images and so on, depend on your requirement. Right. So let me move on. So I will say concatenating matrices. Right. First of all, create a 3 by 3 matrix filled with 1 to 9. Second one, create a 3 by 3 matrix filled with numbers 9 to 1. Okay, give me the commands. So in this one, we discuss how to generate a vector filled with 1 to 9, a 3 by 3 matrix. For first, we generate the 9 elements using arrange, and then we reshape it to 3 by 3 matrix. Similar to that, we generate first numbers 1 to 9 to 1, and then we reshape it 3 by 3. So these are the two matrices now we have. Right. Let's move on. I'm going to use two techniques. One is you can use concatenate, and we can say A comma B. So when I say A comma B, it will concatenate row wise, which you will get something. Okay, in B dot. Okay, we miss two brackets here. Yes, it's row wise because you have 3 rows. Now it becomes 6 rows. The same answer you can get in another command we call np stack. We have a command, right? You get the same result. So make a note of this. We created a 2 3 by 3 matrices. And first one, we discuss how to join, concatenate them in row wise. If you study carefully about the concatenate method, if you want to make it a column wise, we have to set what we call something called axis. So look at that information for axis. Right. So let me show you A and B separately. So this is A. So it's 3 by 3 matrix filled with 1 to 9. Second one, what I said, we create a 3 by 3 matrix filled with 9 to 1, right? So that is where we have started A and B. A, we have a 3 by 3 matrix filled with 1 to 9. B, we have a matrix filled with 9 to 1. Okay. The first one is how do you concatenate row wise? We use concatenate method. We simply say A comma B. Or we use V stack. We say V stack also, we say A comma B. So it concatenated row wise. Why we say row wise? You have 3 rows in both. And when you combine, you get 6 rows. We say row wise combination. And this is denoted with the axis. Axis value is always 0 in row wise. If you want to make it column wise, you use axis 1. Right. So here we have used concatenate A comma B, V stack A comma B, row wise. If you need column wise, we use concatenate A comma B, and axis will be 1. So if I run this, you now notice that we have 6 columns. The same we can use hstack as well. So both commands gives you or combine the 2 matrices in column wise. If you ask me like what are the practical applications, okay, we can combine dataset, we can combine images, okay, whatever that you want to combine, you put into matrix form and if you combine, you can use this. Right. Last couple of ideas. The transpose of a matrix, matrix transpose. So we'll say print A and A transpose, you can notice. A will be 1, 2, 3, 4, 5, 6, 7, and 8. When you transform it, you will get 1, 4, 7, 2, 5, 8, 9, 6, 3. So 9, 6, 9. So that will give you transpose. So A and A transpose. Make a note of this. So the next part, I would like to discuss about some elementary functions. So I will explain 2 of that commonly used, but what do you mean by elementary? Is these methods, the functions works element by element, right? So already what we know is we have A and we have B. So what is A? We have elements from 1 to 9. We have 9 to 1. Now, element method means it works element by element. So if you print np.add A comma B, what happens here is it will add the first element with the first element. So 1 plus 9 is 10. 2 plus 8 is 10. 3 plus 7 is 10. So ideally, we should get tens as the answer, a 3 by 3 matrix. So hope you understood what add method does it here. It's called elementary function. It adds element by element. Similar to that, instead of add, use multiply A comma B, you will get multiplication of each and every value. So the next one is multiply. Again, elementary function. If you use np.multiply, and if you say A comma B, what happens? It multiply individually. I made a mistake somewhere and I couldn't figure. Okay, we don't need like brackets like this. Okay, too many brackets. That's where the problem is. Yes. Okay, so in this particular case, you just list A comma B and multiply. What happened? Each individual elements multiply each other. Right. So now I think we have covered about elementary functions. There are many others. You can use multiply, you use divide, subtract, and so on. But if you need to work on real matrix manipulation, you have to use dot, right? Dot one with map the rows and columns. So for example, we can use print np dot dot, and then you will say a comma b, dot operation between a and b, and this is what you will get. I would like to discuss like some of the functions that we can apply throughout the matrix. This will be helpful when we work with the data sets and so on. First of all, let me explain how you may use getting average, summation, and also standard deviations, right? With matrices. So I will start with getting mean values. So let's take our 4x4 matrix. So let me say x nb dot arrange 1 comma 17 will create a vector which consists of numbers 1 to 16, and let's reshape it to 4x4, right? And when I say print x, so we know x is a 4x4 matrix like this. Right, now let's say we take mean value. So the command for getting mean is np.mean, and I can say x, and what happens, you get a single value. So what we get 8.5, it means when you add all the elements together here and divide by 16, we get 8.5. Similarly, you can get the mean row-wise and the column-wise, right? Row-wise. So let me explain. Let me say print np.mean x. So you can say x comma axis. If you put 0, you will notice what happens. So if you put axis here, which means, okay, calculate the mean value along the axis 0, which means row-wise. So you can calculate 13 plus 9, 22, 27, 28. Divide by 4, you get 7. 14, 10, 24, 30, 32. Divide by 4, you get 8. So this is row-wise. Row-wise mean. So we can say row-wise mean, right? Similarly, if you use mean x axis equals 1, then it's column-wise, this direction. So you will get column-wise. So if you print this time, you will notice that we have 1, 2, 3, 4, 6, 10. 10 divided by 4, you will get 2.5. 5, 6, 11, 18, 26. Divide by 4, you get 6.5. Column-wise mean. So that's about getting mean. So if you just directly use mean, you get the mean value for just single number, and all the elements divide by the number of elements. If you specify axis 0, you get row-wise mean. Axis 1, you get column-wise mean. So similar to this, you can use standard deviation, sum, product, right? There are methods related to this. So let me do the same for sum. So we'll take one more. We'll take print x. We have numbers from 1 to 16. Print np dot sum x. We'll sum all the elements, that 136. We'll print np dot sum x comma axis 0. The sum along the rows. Sum along the columns. So this is what we get. So similar to that, you can use product as well. Right. If you're finished, just let me know by. So in this one, what I've tried to explain you is how to solve an equation in the form of AX equals B form. If you look at with the theory, we have, let's assume that we have two equations, x1 plus 2x equal 10 and x1 minus x2 equals 7. So if you want to put in the matrix form, you can get all the coefficient into one matrix. Let's take A, and we have x equals B form. So once you have AX and B form, to solve this using NumPy, we can first represent A and B, and then we can use np dot linear algebra solve method, where we put A and B, which will give you the rows. Right, so that's all what I want to discuss for today. But then we'll have a quiz time, that I want to have a small quiz on the things that we have covered on today's session. So let me share the quiz for you. Make sure that when you logged in, right, when you log into this, use your index number so that I can keep track of your progress, as well as you'll get some marks for the participation as well. Right, we have just 9 questions and then we'll finish for today. So let me share this with you. Please log into